Hey guys, Big Boss here. Exercise number 13. They ask us to find the domain of a function. In this case, we have a two-parter, so we have part A, f of x equals square root of x squared minus 2. And then in part B, we have f of x equals x that multiplies the square root of x squared minus 2. That is our two-parter for number 13. And before moving forward, I want to clarify that throughout the series, I'm going to be using y equals f of x interchangeably. They are absolutely the same. So just for clarification. Having that said, let's move on to our table of functions. We have not a constant, we don't have linear, we don't have polynomial, we don't have division, we have a radical function right here with an even index in the root, just to make sure we don't have logarithmic, exponential, or trigonometric. So we have to be aware of the restrictions of a radical function. In this case, a radical function with an even index, which means that the inside has to be positive on both cases. So let's get started with part A, and we're gonna rewrite f of x equals y equals square root of x squared minus 2. And again, the inside of the root, the argument of the root, has to be positive. Therefore, we must comply that x squared minus 2 must be greater or equal than 0. That is to guarantee the existence of a square root. Why? Because square root of negative numbers do not exist. So an equation that we have to solve is x squared minus 2 greater or equal than 0. Once we solve this, we will be able to find the domain of function A. Therefore, the intervals of existence. So let's do that. Let's solve the equation. We have x squared minus 2 greater or equal than 0. I'm going to pick up the pace right now. So to solve this, we have to add 2 to both sides of the equation. They cancel each other on this side, and we end up with x squared greater or equal than 2. And now, to get rid of the square, I have to apply square root to both sides of the equation, or you can also power to 1/2, it's the same thing. And you end up with x greater or equal than plus minus square root of 2. This is our solution. Since we have a greater or equal logical operator, we have to apply a union of both solutions. So here we have our x-axis of real numbers, minus infinite plus infinite. We plot minus square root of 2, square root of 2. Like, remember that we have greater or equal, so we're going to have two solutions. The first one is from minus square root of 2 to the left towards minus infinite, and from square root of 2 towards the right towards positive infinite. And there we go. Those are our interval solutions. Now, how do we write it? Well, we can do it in two ways. We can say that the domain of the function is all the real numbers minus the restrictions, meaning the interval of unexistence. Or we can also say that the domain of the function is the intervals that are solution to the equation that determine the existence. So let's do that first, which is domain of f is all the x's that belong to the intervals from minus infinite to minus square root of 2, union with square root of 2 plus infinite. And there we go. That is the solution. We can also rewrite it, like I said at the beginning, as the domain of a function is all the real numbers minus the restrictions, which is minus the interval where the function does not exist. In this case, minus the interval minus square root of 2, square root of 2. Why? Because inside this interval, the function does not exist. And here we go. We lock this in. Here we have our solution. Either of them are equivalent. And if you want to try to test if the interval restriction is correct, you can use minus 1, 0, 1, and plot them into the function. So let's do that. Let's try f of 0, and that's going to result in 0 squared minus 2 square root of minus 2, which doesn't exist. Let's try f of 1, and this is going to result in square root of 1 minus 2 equals square root of minus 1. It doesn't exist as well. Therefore, the restriction is correct. So, having that said, let's move on to part B. And we're going to write B, y equals f of x equals x that multiplies square root of x squared minus 2. Quite similar to part A. Again, we have to make sure, we have to guarantee that the orange circle part, the inside is positive. But then again, we have an interesting case right here. Now we have an x that is multiplying the root. So let's take that into consideration. But first, let's address the restriction. So again, x squared minus 2 has to be positive, meaning it has to be greater or equal than 0 to guarantee existence of the function. Now, because we solved part A, we have the solution for that. We know the intervals in which x squared minus 2 is positive. So those intervals are going to be the solution to the function. So because of A, we know that minus infinite minus square root of 2 union with square root of 2 plus infinite is the interval of existence. So therefore, the domain of the function or the solution is the x's that belong to the interval minus infinite minus square root of 2 union with square root of 2 plus infinite. And there we go. That is our solution. That way we guaranteed existence of the square root. Right? 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 Wrong. We missed something. Just because an exercise looks alike doesn't mean it is exactly the same. In this case, we have to keep in mind the following. Remember when we did the test of the values of the intervals of unexistence, the restriction interval? We did f of 1, right? And that resulted in an unexistent value, which is correct. But in this case, in this part B, in this case, if we do f of 0, due to the x that we have here multiplying the radical part of the equation, this x right here, if we do f of 0, you're going to see something quite interesting. So let's do that. F of 0 equals, replace the 0 wherever you see the x, f of 0 equals 0 that multiplies square root of 0 squared minus 2. Like this, which is, of course, f of 0 equals 0 multiplying square root of negative 2, which is 0 multiplying something. It doesn't matter if it is a negative square root. We have a 0 thanks to the x multiplying square root of negative 2. But that is 0. Why? Because of the property from arithmetics that says 0 multiplied by anything is equal to 0. That is a property, a very well-known property. So in this case, 0 then is going to be part of the solution of the domain, thanks to this property. Interesting, huh? Well, that's why we always have to monitor that x factor element that is now affecting the square root. So, having that said, our real solution for the problem, the domain of f is all the x's that belong to the intervals of existence of the square root, which are minus infinite, minus square root of 2, union with square root of 2, positive infinite, union with the number 0. And this, my friends, is our true, real solution. Here you have the graphical representation of it. Here's the x-axis. So you plot minus square root of 2, 0, and square root of 2. And you include number 0. And this whole thing, my friends, is the entire solution of the exercise. Note how the x that multiplied the square root was a factor to take into consideration. This x right here, that's what made the difference because it added a value to the domain of the function. Big Boss out.